Well, good morning, everybody. I wanted to start off today just reminding everybody this is solstice. It's the winter solstice for the northern hemisphere and the summer solstice for the southern hemisphere. And it's kind of a couple of fun things you can do with a GOES full disk image like you see here. Now remember, the satellite that's taking this image is in a geostationary orbit, meaning that the orbital period of the satellite matches the rotation of the Earth. And it is far enough away to kind of see almost a full disk. It can almost see the entirety of one half of the planet, but remember, because our planet is a spheroid, you can't quite see pole to pole and on the edges here. But what I want you to notice today is right here. This is where the day-night line is as the sun was rising here across North America and then already risen across South America. A couple things to point out. We're going to talk about this again at the end of the video. There's quite a bit of cloud cover down here, something that's really going to be important for this upcoming forecast. But if I draw that line again, that kind of day-night line here, what you do is you find the equator, which is roughly about right in through there. And then if you draw a line pointing directly toward the sun, what you'll find is that the angle that is created between the equator and that line is 23.5 degrees, which represents the tilt of the Earth on its axis. So today the sun glint, wherever the sun's rays are going to bounce off of the ocean, you'll see them on satellite, will kind of trace out 23.5 degrees. So it's kind of a neat thing here. Now we call it solstice because it means sun stop, and that basically tells us that this is the farthest into the southern hemisphere that the sun's direct rays will achieve. And after this, they're going to start to retreat. Now, I live way up here. Of course, you all know that. I live south of Chicago in a town called Champaign. It's about 150 miles or so south of Chicago. And in Champaign, today, the sun angle will barely get to 27 degrees off the horizon. Despite the fact that Earth, as you know, a celestial body, is the closest it gets during the year to the sun, the low sun angles and the short amount of daylight hours, which today, of course, is the lowest amount of the entire year for the northern hemisphere. Well, anyways, that's why it's cold. That's why it's winter. You would think that would give the southern hemisphere, being closer to the sun with longer daylight hours, much more dramatic swings in their seasons, but they don't have that because most of the southern hemisphere is made of water, which has a thermal inertia about 5 times that of land. So it's a big regulator. The oceans are the Earth's massive climate regulator. So it's a fascinating day. And after this, we begin to gain daylight hours in the northern hemisphere, and they're lost in the southern hemisphere until June 21st. Now, that's just a little bit of backdrop to what the day means, but I've really been thinking a lot about this. One of the great things about the U.S. Drought Monitor is that you can do the comparison slider. It's under the Maps tab. You just come right down here to comparison slider, and you can choose your dates. So on the left of this line, which is what you see here, I have December 14th of 2021. I went pretty far back here. In fact, maybe let's not go back to 2021. How about we go back just to 2022? I was just looking at the extent of the drought in the West, and I figured let's just go back to last year. So now you can see it. This is where we were a year ago. All right. Now, the drought had already started to break in the West compared to what it was in 2021, but still, we had quite a bit of drought in the plains, and California entirely covered in it. Well, then what I want to do is I just slide this across because the other side of the image is now. Now, we'll get a new drought monitor in about an hour and a half after I record this, and it's just amazing just to see the changes that last winter made. So, I mean, that most of the drought relief you see in California was last winter, part with Hurricane Hillary, and then that big deep trough that kind of flooded out Nevada and California late summer. That was the Burning Man trough. So I find this fascinating. The other part of this we got to talk about is the development of drought in the Tennessee Valley, the MidSouth, the Delta region. I want to have a good look at that here in a few moments as well. But let's stay out west for just a second, because lately there's been a cutoff low that's kind of just slowly meandering toward the south. That's going to be our main player over the next several days, coming across Arizona, New Mexico, finding its way across the rest of North America, or at least the United States here, delivering quite a punch in and around Christmas. But in the last 72 hours, we've had some pretty heavy rainfall move through California. Parts here of like the Klamath Mountains, the coastal northern side of California, has picked up in some places well over 6 inches of rainfall. Now, not a lot of that's been snow. You look back over the last 72 hours, and the snowfall totals have been pretty light overall for what we can get this time of year. And there's quite a few reasons for the fact that we've not been able to really pile up a lot of snow in the West so far. Almost every attempt we've seen of big snows coming in the Cascades, for example, have been followed by too milder conditions and even rain on top of them. And while we're doing all right on the snowpack that's showing up here in the Rockies, I think a lot of folks that are going to be taking trips out there to ski are going to be finding that the snow is maybe not quite, maybe the quality or the depth of as to what we would really want if you got to pick and choose. So I want to compare this map to two other maps. This is the season to date percent of normal snowfall. And you can see that throughout parts of Colorado, we're doing okay. And then you get down here into this part of Mexico. But take a look at the Sierra Nevadas. A lot of single digits are up to 20 to maybe almost 30% of normal for this time of year. And while you see the values up here in the Cascades showing right about average, remember, every time we've had big snow, it's kind of been followed by more mild conditions and at times wet conditions. So we look around the rest of the country and we got big questions to ask about this winter because last winter just did not deliver the snow throughout parts of the Midwest, all the way over to Pennsylvania, even New York. This was just an area that was left out of the snow wall. It was huge snowfall amounts in the northern plains, upper Midwest, and of course the whole western mountains. That's why we started off with that drought analysis. But coming back to the west, just one of the websites we'll check into a lot over the coming weeks and months. This is from NOAA, National Weather Service, and it is using data also from the USDA and the USGS and a lot of different sources to basically give us an idea on snow water equivalent. So the map is actually put out by NRCS, so just kind of give you all the alphabet soup of acronyms there. But what it looks at here is these different basins throughout the West and tries to show you where they stand compared to historical averages at this point. And the reality of it is that even though there has been moisture coming to the west, it's mostly been in liquid form, and we have yet to really build up, decent, or what I would say big time snowpack, which I think a lot of us would want to see again this year for the Colorado Basin, for all of the river systems in California, and then throughout the Pacific Northwest, the reservoir systems really need to see these good snows. Now, we can blame this on a lot of things, but just one thing to think about is the end result of everything I just shared. December's been mild, and if we look at this, we can see throughout much of the United States here, we're having certainly in the top half of the distribution, but across the northern tier of the U.S. and then along the west, we're having a very anomalously warm go of it. And we got several things to blame on this, right? We know there's an El Nino. What does El Nino typically do? It tends to enhance the subtropical jet stream. That's the one that's farther to the south. It tends to make the polar jet, the one coming out of the Pacific, more variable. We have yet to get big ridges of high pressure over Greenland or Alaska that can stay in place long enough to shove cold air here. So the end result is we've just had a lot of mild air, and we're going to take a look at how much longer this is going to last and maybe when it's going to break over toward giving us more than just a shot at cold air. Now, just a reminder, in the upcoming forecast, I'm going to continue to show you that it's mild, but there are shots of colder air in the setup. You'll get maybe a day or two of some really cold air, but it just doesn't stick around because the pattern's not conducive to it. And the other thing to think about here is just to look globally as to where the cold air is locked up. And if you look across the northern hemisphere, we've got a lot of it over Greenland and parts of the North Atlantic. You got some of it that's still here over parts of, this side of Siberia, Russia, coming into Alaska. But really, the central parts of the big continents here don't see it. And sea ice is still, the concentration is still a bit low for this time of year. And on top of that, polar vortex is sitting over Greenland. So we've not yet seen the combination of events needed to really just pack and pile cold air in. And another thing to think about here is that also means we haven't built up a big reserve of it just yet. Now, let me be very clear on something. Well above average temperatures throughout Canada and the Canadian archipelago, if we were to take these temperatures and move them south, it would be very cold compared to average down in the States. But to see a deep reservoir of cold air building somewhere in Canada, which is what's often needed to make these monstrous high pressure systems which help deliver, bigger lows that roll across the United States, it's just not there yet. So I want to point those kind of things out here as we work through this forecast. So here's the other thing I was thinking about this morning. Over the next 15 days, we still have our jet extension. So we're going to be seeing some wet conditions try to move toward the west coast. It all depends on how far the jet extends before it starts to split. And it's that split that's bothersome because we've seen it come up and around and over the top like this and follow the subtropical jet stream around. So again, we just kept getting that northwest flow at times. Now, what this is, this is primarily from the system off of California right now that moves through Arizona where we have flood watches this morning and then emerges. The GFS and the European model have entirely different solutions on where this is going to go. Now, I can explain away the dryness in the northwest. You just get flow that splits. You don't get the strong onshore flow. California being wetter, well, that's where the cutoff low is. But one of the things that's been bothersome to me has been this part of the Mid-South to the Tennessee Valley, back to the Delta, maybe up to the Ohio Valley. And I've been thinking a lot about that area since the start of this fall, honestly, because fall ends today. And if you just go back, I just picked October 1 as an arbitrary start date here and went to yesterday. That whole region of the Mid-South, the Delta, back up to the Ohio Valley, has been very dry. And you just saw in the forecast, not a whole lot of relief coming. Now, we do see the relief coming here into California and Arizona, which is desperately needed. But I want to talk about this area just for a moment here. So what I'm going to do is I'm going to pull up a couple of just different ways to look at it. We know that since November the 1st, we have favored a ridge of high pressure in the upper levels of the atmosphere here. And there's been lows and troughs of low pressure in Alaska and also at times across eastern Canada. What the flow has done is it's come in pretty fast. At times it's cut off like this, which you've seen. It's doing that right now. And then it kind of splits and goes over the top. And what this does is it brings flow around this high pressure cell that is delivering air a lot of times from Canada. It's been briefly interrupted a few times by systems that have tried to sneak out and get through here relatively quickly. But the issue with this particular ridge of high pressure is that when you go back and reconstruct, I just picked the Tennessee River Basin as an example. If you reconstruct from 1895 to 2022, the November and December total precipitation, I wanted to know what made these really dry years that poke down on the time series. I do also want to point out that I just chose 1970 as a start date and put a trend line on it. And there's very much a slight downward trend to the tune of about 0.13 inches per decade. Very slight downward trend in November and December precipitation for the Tennessee River Valley. So what we can also do with this is I can come in and say, well, show me what the upper level pattern is doing. In fact, let's go to the next one here. Look where we typically see ridges, somewhere in the west, with deep troughs here or over Alaska or over the, between Alaska and Hawaii. We typically see this as the mid-level pattern. So what do you end up getting out of it? Well, you get flow that sneaks in like this, or it comes around and grabs that. And then what does it do? It has to dive out of the northwest here. And for some reason, this pattern, because of that northwest flow, tends to prevent any system that breaks through this temporarily from really just drawing an abundant amount of moisture and putting it into the Mid-South. Now, this is just one aspect of this. If I dove into all of those aspects, you'd be listening to me for another couple of hours. But it's the most critical one that we can continue to observe. We need to just pay attention to that because, I'll go back to that graphic I showed up with just for a second there. See that? That's what the anomalous flow looks like. So then the subtropical jet sneaks under it, comes out here, and what needs to happen is you got to put this right back over the delta in order for things to really shift around and to get better flow. So this is what's going on, and what I'm concerned about is you just look at that 15-day forecast and it's missed again. Now what's interesting is the plains are going to get a good dose out of this, quite a bit of good precipitation out of this, and that's all going to be complements of this slow-moving cutoff flow. Again, cutoff means the main flows to the north of it here. There's flow to the south of it, and it's just sitting and spinning as a closed low. That generally means it's a bit slower. Right now, what we've got is flood watches that have been issued for parts of Southern California getting into Arizona, and this is desperately needed rainfall. Outside of that, we still have the flooded areas in New England from the storm system over the last 7 days. Also down here in the Carolinas, got a freeze warning again for this part of Georgia. And then you notice some dense fog areas where we've had a lot of dense fog as of late. Now, one of the reasons for the dense fog here is that the temperatures are beginning to warm up a bit, and there's a lot of moisture coming in with that. So as they dropped last night under some clear skies, that's how you got the fog in this area. But take a look at the high-res NAM. Let's pick this up right about when I'm recording this, about 6 in the morning Central Time. As we play this forward, watch out ahead of it. There's this kind of plume of moisture. Where's that coming from? It's rolling around the high-pressure area that's sitting over the southeast. But the main system is still sitting and spinning off of Southern California. And it starts to deliver in the overnight hours into tomorrow morning some of its heaviest rain. Look at that coming into Arizona. Now, you know why this is important. I mean, just look how dry things have been down here. So to start to see that moisture coming in is just great to see. Meanwhile, it's going to be a bit soggy in parts of coming out of Oklahoma and Arkansas, Missouri, Illinois, Iowa, pushing up to Wisconsin. This would be Friday, tomorrow. And that moisture pushes into Michigan, Indiana, and over into the Eastern Corn Belt, Eastern Great Lakes. But let's just stop this about Saturday at 9 a.m. And what we've got out here is a pretty well-developed low that's going to have I think, the right ingredients to start to make a decently sized system. Now, the question about this system is, after it comes through the four corner states, how slowly does it progress across the country? Because if we could get this system to dig and then roll up, then I wouldn't be talking about drought issues here. What we'd be talking about is plenty of rain, in fact, probably more thunderstorm activity. But I want you to see the evolution of this low past this point. So I'm going to bring back one of my favorites here. I got the GFS trough ridge pattern, and I have the European trough ridge pattern. It's always a model comparison between these two. So as I play this forward, what I want you to see is we get out here towards Saturday. Now on Saturday, let's actually go right here to 6 p.m. If you notice, there's the main trough. It looks pretty similar in the models. But look at the one to the north of it right there. And that's just the first part of what's going to be different between these two models, because they go from Saturday into Sunday. Did you notice how the trough that was over Idaho and the European dug into the backside of the trough to the south? Whereas over in the GFS, they kind of merged together. Now you're kind of saying, well, what's the difference? Well, if you toss a trough, a shortwave trough, into the backside of a bit of a longer wave one, this isn't a true long wave, but a bigger one, what ends up happening is it forces them to kind of, do this orbiting motion like this, slowing the whole system down. So if you notice right now, this is Sunday, 6 p.m., the trough of low pressure, because of the combination, is over kind of southwestern Colorado. The GFS has already ejected it here into Texas, with the northern piece coming out of northeastern Colorado. Now, that may not seem like much. You blur your eyes, you don't even really see the differences, but the difference really shows up when you get out here to Monday on Christmas and moving forward. Now, why? What this does is this creates a deeper low through the combination of those two troughs, a slower low, and notice the European model has a much more defined trough coming in on the backside. These are very subtle shortwaves, And what the end result is that the GFS kicks this all out quick. Look, the low is already over like southern Indiana, Evansville. Where is it in the ECMWF? It's still sitting over like southwestern Iowa. So this means this system lingers, the GFS ejects, and as we just play this out there through Wednesday and Thursday, the end result is one system gets farther to the east quicker, that's in the GFS. European lets it linger. So I'm trying to show you all of these things, and this is not to ignore the next wave that comes into the northwest, or the huge ridge that builds on the Rocky Mountains that puts all this high atmospheric pressure over Canada. It's just to show you the subtle differences so that when I show you these animations here, you can see why the models are treating the systems differently. So we've already seen through Friday into Saturday. Now watch. Expect to see the European giving the slower solution with bigger precipitation totals and more snow. The GFS kicks it out quicker. So here's Sunday morning, 6 a.m. This is on Christmas Eve. This would be noon, getting into afternoon and evening, and then getting into early Monday morning. So this is actually 6 a.m. Monday morning. Now already you can see, look at how much more developed the low is on the backside here versus the GFS, which is pushing this east and then just dropping high pressure in here. Now I want to be clear, there's going to be some rain that comes through that dry area in the Mid-South. But in both cases, it's not like it's a sustained long rainfall event. It just kind of comes in and maybe ruins Christmas a bit here. But then after that, watch the GFS, which is on the left, and how it curls up the low versus the European. Look, the European's leaving ice on the northern side of this for midday Tuesday, snow back in the Dakotas, part of the South Dakota and Nebraska, and nothing in the GFS. It's already out. So the European model just slowly lets the system evolve. The GFS has already got it through the northeast. I was looking at the northwest when I said that, because that's when the next wave comes in the northwest, hits northern California and up the I-5 corridor. But that's why these two systems look so different. It's all because of the interplay between very subtle shortwave features. And that is where the error in our forecast is going to come from. Because if you think we've actually sampled those shortwaves well, we have not. This is one of the trickiest things about doing weather forecasting. But I can show you the comparison. Ready? That is the European model 7-day total accumulated precipitation. So this gets us out there to 6 p.m. on Wednesday the 27th. This is the same forecast from the GFS. So look at the differences there. One much farther east than the other, right? The GFS wetter east. And you can even see it when I compare it. Notice how much wetter the GFS is here. It's faster in progression, brings more rain to that Tennessee Valley area that needs it. The European slower, delivers more of its rain back to the plains. And that's by the way, again, it's just one portion of an analysis of this. There's a lot of very complicated features that go into it, but we just try to bring that to you to kind of show you what we're looking at here. So other aspects of this, I do want to point out that only the European model is putting down the risk of ice. And so through next midday Tuesday, I want to watch this area carefully in the model forecast evolution, just to let you know that there are some solutions trying to put down the risk of some ice in this area. And again, when does that start? It's starting here on Sunday, going through Monday and reaching its kind of peak by Tuesday as that low slowly moves. So this could be some pretty, if this verifies, some pretty rough travel conditions right in through this part of the Dakotas, Nebraska, maybe parts of northern Minnesota. Okay, from there, let's take a look at the snowfall totals. You know that the European is slower, so watch it put down the snow in the Rockies first. This is getting out through Monday at 6 a.m. So we're again looking at who's got that chance for a white Christmas. Well, the European has a different solution than the GFS, as you can imagine. If you are a snow lover, then you're going to want to take the Euro for what it's got. Because over the next 7 days, it's putting down the biggest snows right here from Kansas to South Dakota. Remember, ice right in through this area. The GFS has got this. So if you want to see it, sorry, there we go. The GFS, here it is. This is Saturday, getting into Sunday morning. Sunday evening, getting into early Monday morning. It's trying to put down a stripe of snow from, north of Omaha, but through Sioux Falls all the way up here, just north of Minneapolis, straight up into parts of Ontario. Entirely different solutions right now, all because of the interplay of these short waves. So here's the comparison. European, GFS. Now, to show you who's going to be wet with all of this, this is the chance of getting an inch over the next 10 days. And I love seeing this. Now, you know that this area is a bit drier because of the speed of this system, but to see the moisture coming into this area is a very, very good thing. There are parts of the upper Midwest. In fact, a good friend of mine, Eric Hunt, did some analysis and found that there are sections of Iowa that are 20 to 40 inches off of normal for the last 4 years. I'm going to work on kind of doing a similar analysis as he did with a different data set just to see if it matches. But just amazing to see we got good moisture coming into this area. It's desperately needed. The Mississippi's still about 5 feet below low stage at Memphis, and I've shown you those soil moisture maps many times. But let's use this. Actually, I'll come back to this in a second. I do want to point out, though, the good news is that with all of the mild air that's going to be in place, we'll have soil temperatures on Sunday when all this rain starts to get into this area. And then the following days, the soil temps are going to be up 50 on that contour line, 50 degrees Fahrenheit. And why I like that is because this is going to soak in. So that's just another component to this overall. Hang on, let's come back here. Let's flip this away from precip and total precip and go to probabilities for snow. So I probably got a new model running while I started to record. I did. So let's go back to the old one. There we go. How about the chances, of getting an inch of snow through, let's just stop it there on the morning of the 26th. So this is your new snow. No, that's not an inch. That's 3 inches. There's the chance of getting an inch. So we're just kind of identifying those kind of areas that have a chance at white Christmas. The heavier snows, let's stretch it out a bit farther. How about all the way up to day 10? Best chances of 3 inches are coming into this area according to the European model. Now after this, I flashed this a moment ago, we still expect the jet to extend. I mean, it is really starting just here off the coast of the Sahara, goes all the way across parts of most of Asia here, exits Japan and finishes right here. Now you know the problem I'm going to tell you this has, the split nature to it. And we have to correct that. That's got to be displaced. I think in order for it to be displaced, we got to get some sort of big change happening in Alaska. That will help. We need to also get its establishment of colder air here. Because just imagine, if you put cold air in place here, what will the jet stream have to do? It has to go south of it, and the polar jet starts to form. So we need to just be patient to wait for when that's going to happen. I got an idea about when I think it's going to happen, but the reality of it is in the near term, getting us out there into week 2, we'll even just use the CPC's forecast here. The 28th through the 3rd, we just noticed that northwest flow continues to dominate this area for drier conditions. While California gets the benefit of the extended jet, so does parts of the south. Okay, from here, let's talk about the temperatures, because today is a very mild one for the midsection of the country. We get into Friday, it even expands, and getting into Saturday, look at that. I mean, mid-50s in Iowa. Just incredible to see those warm temperatures this time of year. Sunday into Monday, this is when the low starts to make its appearance, right, and spins up. So we got the cold air on the backside, very mild air out ahead of it. So this is what I like this. I know a lot of you would not like to see this, but I'm only thinking about agriculture here. And to keep it warm means that the water soaks in, and that's what we want. We don't want frozen soils just yet. So very mild Christmas Day. Getting into Tuesday, it'll be mild and wet, and we play this out to next Wednesday, and we continue to see most of the northern half of the country with mild conditions. If we just take a look at what the overall kind of placement of that most mild air is, you can see where our cold air is. It's here, Alaska, Bering Sea, Chukchi Sea. It's over Greenland, not in the center part of North America. About the only place that'll stay cooler than normal will be the south, where the subtropical jet stream lives. Now let's stretch this out a bit before we go on to South America. Newest European model forecast is really pushing the MJO out here pretty high amplitude into phase 1. In fact, we can see that by looking at the velocity potential. You're looking right here. And over the next 10 to 15 days, there's going to be a lot of rising motion that occurs in this area. There's a complement to it happening in the next week or so that's right here that sits right on top of Brazil as well. So we'll have to talk about that in a few moments. But if we watch the progression of this, knowing there's typically a lag in when the MJO moves somewhere and what it does in North America, when are we going to get the phase 1 lag? Will it happen in December, or will we really have to wait until January to get this phase 2, phase 3 set up? Because if it happens in December, what we end up, in early January, that would be our next month. Forgive me, I got the months a little bit screwed up there a moment ago. We still don't cure this problem. See that? And there's the subtropical piece. But if we do get, by mid-January, some more of the phase 2 action, this is what I've been talking about all week, this would be the pattern. This would tell you, the whole country honestly gets lit up by a pattern like this. Canadian prairie finally gets some moisture out of this. So we need to see, just in order to get some normal winter weather in here, that we get a phase 2 with probably a week to 10-day lag on it, meaning mid-January, to see something like this happen for maybe a week or so. Deep troughs rolling through here. This is a lot of lows coming out of the southern plains and then rolling up the east coast. This is an elimination of the northwest flow in Canada. This would be it. We need to get it here. Some of the models are starting to see it. This is Jan 4 to Jan 10 from the CFSV2, precipitation anomalies. And then this was Jan 11 through Jan 17. And you start to see the breakaway here about mid-month to something a bit more active. The next one I'm going to show you is from the European Extended Model Forecast. And it keeps mostly the southern tier of the United States active for January, a little bit drier in parts of the Ohio Valley. But I still think that there's going to be a mid-January flip on this pattern. The GFS Extended, this is its forecast, 30-day outlook from the 24th of December through the 24th of January. Just another way to look at it. I'm not putting a whole lot of stock in either the European or the GFS right now. I'm going to put it more in the pattern evolution, getting that MJO to move around. So with all of that, I'm going to leave this up there and we'll keep thinking it through. We'll talk about it again tomorrow. But what I want to do is talk a bit about South America because we got some new NDVI data in. And I got to be honest, this was a bit surprising. Mato Grosso, right on the climatological average. Now remember, this is a place that's seen near record dryness. Only drier year since 1940 was 1942 and this year. And you come over to Mato Grosso do Sul and the NDVI values are even above a year ago. And we take a look at Goiás. This is one spot where it is a bit lower. Let me turn off Mato Grosso do Sul there. You can see the values down here near the climatological low. But I have some friends down in Goiás that have been talking about the crop, and they just keep saying it's okay. They don't say it's great. They don't say it's destroyed, but they just tell me okay. Let's go down to Paraná. Paraná has right now, very high NDVI values, and we just kind of add up the whole of southern Brazil where all the very wet conditions have been, including Santa Catarina, and you can see we're at the highest end in the distribution. Now, look at this before I get to the forecast. Come over to Cordoba. Let's add Buenos Aires. Let's add in Santa Fe. These NDVI values have been rising as the moisture's coming in, breaking the long-standing drought. That's critical. Coming back to Brazil, what has also changed is the wind direction. Remember us talking about this yesterday or day before? Look at that coming in. This is going to start to develop what we would call more typical monsoonal moisture. So I'm going to play this fast because I want you to honestly step back from the computer or your phone and blur your eyes and just watch. You're going to see fronts that come up like this and flow that comes around like that. That is what we would call normal for South America. So here we go. Can you kind of see the whole pattern evolve there? And what it's finally taken is finally taken just, let's go back. It's finally taken the shifting around of those winds, and we get these flashes of green, which represent the monsoon. And then what do you have? These are fronts coming up out of the south. So the long story short here is that you go back 2 days ago and look at the European model, and you compare it to now. This is the latest run, and it's trended the same across the growing areas, a little drier in the Amazon. The GFS has trended much wetter. This was the 6Z run from the 20th. Let's just pop this up to the 12Z run from the 20th. Let's go up another one here to the 18Z run. That one got drier. Then the 0Z run from last night. And how about the 6Z run from last night? I'm seeing a wetter trend across a big area here that needs moisture. So we have to just call this into question as to what this is going to do to the crop. And if it does go wetter, let's just imagine we break off and go wetter into 2024. We have to ask, is that going to get persistent and not move and just stay very wet across these areas that had once been very, very dry? That would actually be very detrimental to the crop there, because it would delay the finishing up its maturity, and then it would also cause problems with harvesting. So there's a lot to be watching here across South America. One last thing, I made a case that El Nino has peaked. We are just a few days away from the kind of historical climatological peak of El Nino, which happens around Christmas to New Year's. And I just want to show you that those ocean temperatures haven't really budged back warmer. They've really flatlined here over the last, well, you can actually see going back to September. Okay, we covered a lot, but here we are just a few days away from Christmas. My last video will be tomorrow, and I'm going to take some time off between Christmas and New Year's. But we'll cover these things again. I appreciate your attention. Thanks.